Today we're going to cover Chapter 7, which consists of maximizing utility. We're going to cover what utility is, the different types of utility, as well as the calculation of utility through mathematical equations, and behavioral economics, and the decision-making of individuals through a behavioral economic aspect. When we're looking at the terminology of utility, utility is defined as the level of satisfaction anyone gets from consuming a good or service. Think about when you go out to eat, when you go out to do an activity, you get some fulfillment, some enjoyment, some satisfaction. That's utility, the level of satisfaction. It's when you eat pasta, when you take a drink, when you consume a product, or when you engage in an activity, sometimes you derive satisfaction. It's not the same thing as usefulness or something that you find useful, and it's somewhat subjective that it's a little bit difficult to quantify in certain situations because we are assigning values or measurements to something that may provide satisfaction to someone. But sometimes what is satisfying to a person may not be satisfying to someone else. So that's why it's a little bit difficult to quantify. Now, when we're looking at total utility, think about the unit of measurement of utility as one util. One util is one unit of satisfaction or pleasure for a unit consumed. The total satisfaction derived is the total amount of satisfaction received from the consumption of goods and services of a specific quantity. Total utility is the total satisfaction of consuming any good or service in quantity terms. So when we're looking at total utility, we're looking at the total satisfaction of consumption of any given quantity of a good or service. When you go out to eat in a social setting, when you go out to a restaurant, when you are consuming a product, you derive total satisfaction from the X amount of goods consumed, or from the quantity of that good consumed, you derive some form of utility in total terms. We have different types of utility. Total utility, which is the regular satisfaction of specific quantity, and then just utility itself, which is some form of satisfaction. At the same time, we have a principle that is referred to as the diminishing marginal utility, where we see that each successive unit of a particular good or service consumed adds less and less total utility than the previous unit. Think about when you consume a pizza. The first few slices or the several slices that you consume may taste really good. That's your level of satisfaction, your utility. But as you consume the entire pizza, you might experience a little bit less enjoyment. Sometimes some people enjoy it a lot. But for the most part, the average person may find it less fulfilling to finish that one final slice. Or when you go out to an all-you-can-eat buffet, where you have certain plates of consumption, and then by the time you're finished eating, you have reached your level of satisfaction that has diminished. The principle of diminishing marginal utility is present in every good or service that we consume. Some people have a higher levels of satiation, meaning that they have a high level of satisfaction that they take longer to become satisfied, and the diminishing marginal utility principle takes a little bit longer or is higher, but it's still present. Now, the law of diminishing marginal utility is very consistent when someone consumes a good or service. So as consumption of a good or service increases, the marginal utility obtained from each particular additional unit of a good consumed declines. It decreases for every good. And it explains sometimes why the demand curve is downward sloping, or essentially why the demand curve is downward sloping as we relate it to the relationship of utility to the demand for goods and services in the market. Think about marginal utility of consumption in this analysis as the change in total utility generated by consuming an additional unit of a good consumed. When you consume goods and services, you get total satisfaction. But if you continue consuming goods and services, then the additional units consumed provide additional satisfaction, but that additional satisfaction needs to be measured and needs to be analyzed. How much satisfaction am I getting from consuming an extra drink? What's the additional satisfaction? If you look at this formula, the marginal utility is marginal analysis, analyzing the change in total utility, which is delta total utility, divided by the change in the quantity of units consumed. So every time you consume a new quantity, it gives you a new utility. You subtract the previous one, the old utility minus the old quantity, to get the change, the total, the marginal utility, or the net change from going from one unit to the next in terms of additional units consumed, and they will give you the specific amount of the marginal utility for that additional unit. Total utility is that if I consume 7 drinks, I get a total satisfaction from 7 drinks. But each unit of the drink consumed gives you different levels of satisfaction. So that's why we want to analyze marginal utility using this particular formula when it comes to marginal utility analysis. Now, if we consider the formula of total utility and marginal utility, here we have tacos that are consumed. Again, this principle is applied to a lot of different goods. We have tacos consumed, which are 1 through 7. The total satisfaction of tacos is expressed. If I consume no tacos, there's no satisfaction. So total utility for 0 tacos, in this case, is 0 total utilities. The total tacos for 1 unit, it's 10 utils. 1 taco, 10 utils. 2 tacos here in the graph, it's 18 utils. 4 tacos, in my graph, 4 tacos give me 28 utils. And 5 tacos, here, 5 tacos, give me approximately 30 utils. That's my total satisfaction that has reached the highest point. And if you continue consuming tacos, your total satisfaction continues to decline because physically you might have been fulfilled. So at the highest point, then is about 5 or 6 tacos that you're fully full. That's your total utility. But if we look at a specific taco, individually speaking, from 0 to 1, we get a marginal utility. The marginal utility. So we get a new utility, which is 10 minus the old, which was none. So we get just that 1 taco gives you a satisfaction of 10 utils. Again, this is an estimate. Your satisfaction goes from 0 to 10. And then if you consume 2 tacos, your satisfaction increases from 10 to 18, so it's rising. But the additional satisfaction that you get from the extra taco or the second taco, the additional unit, it rises by 8, or it changes by 8. 18 minus 10 and 2 minus 1, you get 8 units of satisfaction. So that's, in this case, the second taco. The third taco is giving you 3 tacos minus 2. You go from total satisfaction is 24, you're getting full, you're enjoying the taco, minus 18. Your net additional satisfaction is 6. Notice how your marginal utility is declining as the more you consume, to the point that the 6th taco gives you no additional satisfaction because you're fully fulfilled. So the marginal utility of consumption is diminishing. It's 10, 8, 6, 4, 2, and it reaches 0. The graph for the marginal utility is also diminishing. If you overconsume 7, 8, or 10 tacos, it's negative satisfaction. At that point, the 8, 7, or 9, 10 taco is no longer satisfying. It could be negative, and you might feel unhappy about your consumption. So you need to stop at some point where your total utility is maximized and your fulfillment is the highest, collectively speaking. So when we're looking at consumer behaviors, most of the time consumers were looking to maximize our total satisfaction and stop at a point where our total satisfaction is the highest and our marginal utility has been fully exploited before it becomes negative. So rational individuals, theoretically speaking, should maximize economic decision making and maximize their total satisfaction and recognize that they need to stop at their satiation point to optimize their total utility, or any point after that is no longer satisfying and may be counterproductive or experience negative satisfaction or negative marginal utility. So consumers typically tend to buy goods and services based on their preferences, based on their consumption preferences in the market. And we notice sometimes that consumers can either buy 1 good, 2 goods, 3 goods, or in combination goods. So we're going to assume that a consumer buys in combination goods, 2 goods. And each good consumed has a price. And if we have a good consumed, it has a price, and we typically have income or a budget to spend on those goods. Most of us have income to buy the goods and services, so we're going to assume that we have a budget constraint. Our budget constraint includes our price for the good, price of good X, any good X, the good X itself, price of good Y, any good Y, times the good Y itself. It's equivalent to our budget, and if we're using our budget, then we can only allocate it in 2 different goods, drink and food, and we spend all of our budget. So if we have the drink and the price of the drink plus the price of our food, P of Y, the price of food times the quantity of food consumed, then we have our budget. So we're going to consume a bundle of good X and Y that is going to maximize your total utility. Think about when you're hungry and you want to consume a drink and you want some food, that's your X and Y, the goods that you're going to consume given your budget availability. Now, when we're looking at budget constraint analysis, you always want to optimize your consumption abilities. So a consumer facing a budget constraint is going to be analyzed in a way that typically a consumer cannot exceed your total income or your total budget, whether you're buying food and drinks, or in this case, we're going to analyze buying clams and potatoes. If you have clams to consume or potatoes to consume, so you can only spend $4 in clams. Actually, this is the price of a clam, $4 clams and $2 potatoes, and you have $20 to spend. We cannot spend anything more than $20. That's our budget constraint. Some people may spend more, but we're looking in this case to analyze the fact that we have $20 to spend, and we can buy potatoes or we can buy clams. Question here is how many clams can we buy and how many potatoes can we buy? We can reorganize this budget constraint formula and find the maximum quantity of potatoes if we spend all of our money on potatoes, and if we spend all of our money on clams, up to how many can we buy of each? That's the big question. So we're looking at the consumption possibilities. What is the maximum quantity of clams that we can buy with $20? And what is the maximum quantity of potatoes that we can buy with $20 if we spend all of our money on potatoes, or assuming we don't want any clams. And then if we want to buy all of the clams, and how many clams can we buy? Those give you all of the potential consumption possibilities and the set of consumption bundles that we can buy. Given that particular analysis, we can construct a budget line that will give us the boundary of the budget bundles that we have given our $20 constraint and all of the possible possibilities of clams and potatoes. The budget line means that this is our maximum capability of consumption. We cannot spend anything more than this, and we have all of the potential possibilities of consumption bundles of clams and potatoes if we want to consume a combination of both. If we don't want to consume a combination, then we just buy all of the potatoes and spend $20 in potatoes, or just buy the clams. So let's look at our potential budget bundles. Our budget bundles here, we have already saw we can buy up to 10 potatoes, given that it is $2 each, and we have $20. $20 divided by $2, then we can get up to 10 potatoes. Clams, we can buy up to 5 clams, given that they're $4 each. We have $4 clams, and we have $20. $4 clams times 5 units maximum, that gives us $20 to spend. Again, we have $4 clams. If we buy 5 of them, then 5 times 4, that gives us 20. Then we spend all of our $20 in clams and no potatoes. If we buy 10 potatoes times $2, that gives us $20, and we buy all of the potatoes and no clams. Those are all our possible possibilities and somewhere in between. So we need to illustrate our budget line. We have up to 5 clams if we spend all of our money on clams, and we can buy up to 10 potatoes if we spend all of the $20 in potatoes, or possibility bundles in between, combination of both, clams and potatoes, clams and potatoes. We have consumption bundle A, which is no clams, all of the potatoes. How much are the potatoes? $2. So we spend $2 on potatoes, $2 times 10, that's 20. So we spend all of our money on potatoes. Combination B is we buy 1 clam, which is $4, and then we buy 8 potatoes, which are $2. $2 times 8, that's 16, plus $4, that's 20. It exhausts our budget. All of the bundles can be purchased with $20. And we buy all of the bundles of clams. We buy all of the clams at $4 each, that's $20, and we buy no potatoes. Then we can illustrate this in the maximum quantities. We have our potatoes. We can buy up to 10 potatoes and up to 5 clams. And we can illustrate the consumption bundle capabilities as a budget constraint line, illustrating each specific bundle. Bundle A is 0 clams, 10 potatoes. Bundle B is 1 clam, 8 potatoes. Bundle C is 2 clams, 6 potatoes. Bundle D is 3 clams, 4 potatoes. Bundle E is 4 clams, 2 potatoes, and bundle F is all of the clams. The yellow line, in this case, orange yellow line, indicates all of the potential affordable bundles that we can buy. And inside the line indicates affordable bundles with money left over, and anything on the line we can afford and exhaust all of the budget. And if we underconsume, then we may have money left over if we buy within the line. But for the most part, we typically consume all of our budget. We're looking at here, hypothetically, Sammy buys all of the potential bundles or one of these bundles, and outside our boundary, it's something that we cannot afford yet. We don't have enough money to buy outside our bundle. But any bundle A, B, C, D, E, F is affordable with money left over. The idea here is to find one bundle that is considered to be the optimal consumption bundle. Only one of those bundles is optimal. We have so many bundles to consume, but only one of them is optimal. If we look at the bundle capabilities, we have bundle A, B, C, D, E, F. We have about 6 bundles, but only one of them is optimal. And the way to know which bundle we buy, whether it's going to be 1 clam and 8 potatoes or 3 clams and 4 potatoes, we can only choose one for this instance, for this particular example. We need to find which bundle is the optimal one. The optimal consumption bundle, the one that maximizes the total level of utility given the constraint. Given the $20, then we can only buy one combination. Only one of those combinations, A, B, or C, or D, can be consumed. That's important because we can only consume one of the bundles, not all of them, only one. But once you choose one, you can see that it has to be the one that has the highest level of total utility. We need to look for that optimal bundle. So how do we look for that optimal bundle? Here we have all of the bundles listed. Bundle A, bundle B, bundle C, D, E, F. Then we have the clams, 1 clam, 2 clams, 3 clams, 4 clams. Then we have the potatoes in the middle axis, in the middle of the chart. The potatoes here show we have 10 potatoes, 8 potatoes, 6 potatoes, 4 potatoes, 2 potatoes, and 0 for simplicity. And we have the utility. You're going to be given the utility because it's a hypothetical estimate of what each clam is giving you as satisfaction. 1 clam gives you 15 utilities of satisfaction. 2 clams gives you 25 utils of satisfaction. 25 utils. 3 clams, 31 utils. And so is for potatoes. Potatoes give you 10 potatoes give you 56.7 units of satisfaction. 8 potatoes give you 53.2 units of satisfaction. 6 potatoes give you 47.0 units of satisfaction. So given that we have the utilities for potatoes and the utilities for clams, we need to find the total utility of both goods, good X and good Y, which in this case is clams and potatoes. If you have good X and if you have good Y, we have the total utility of good X, which in this case is clams. We have the total utility of clams. And good Y, which is potatoes, we have the utility of potatoes. We add it together, and we need to find the one that has the highest total utility in order to consider that bundle. So if we look at bundle A, we have no clams, no utility, so that's 0. And then you have 10 potatoes, that gives you 56.7 units of satisfaction. So that's this first empty slot. That's relatively low, so that may not be the highest total utility. Then we have bundle B. Bundle B is 1 clam, which is 1 clam, and 8 potatoes, 8 potatoes. And if you look at the bottom here, the bottom formula, it's that the bundle B gives you 15 utilities for 1 clam and 53.2 utils for 8 clams, for 8 potatoes. Add them together, 15 plus 53, that gives you 68.2 utils. That's a higher total utility combined. You have to add them together to get the total utility of both goods if you're consuming them together. You add the utility of each of them in the bundles. And then we have bundle C, which is highlighted blue. Bundle C is 2 clams at 25 utils, And then we have 6 potatoes at 47 utils for those 6 potatoes. 25 utils plus 47 utils, that gives you 72 utils. So bundle C, I highlighted blue, or it's highlighted blue, shows that it provides the highest total utility for the combination of those two goods, clams and potatoes together, add them together, give you the highest total utility given this example. Any other bundle, like bundle D, bundle D, bundle E, if you add the utilities 31 and 36.8, it's going to give you probably a different utility, but it's going to be lower than total utility. You may practice that for practice. So we're going to select bundle C as the bundle that provides you the highest total utility given to utility of clams, good X, and utility of potatoes, good Y. Add them together, it gives you the total utility. So for now, that's the optimal total utility bundle. So Sammy's total utility bundle is the sum of the utilities for both goods for this particular consumer. As a recap, you should always use this formula when you only have utilities. Consumers typically consume in combination of goods and services, which is known as bundles. And the combination of goods is any good X and any good Y. And then when you have those two goods, you find the utility of each good, good X and good Y, add them together, the utility, total utility of one good, total utility of the second good, and provide the total utility combined in order to give you the highest utility in the highest optimal bundle. Now, in some situations, we want to use the marginal utility per dollar maximizing rule. And the marginal utility per dollar maximizing rule indicates that any consumer can allocate his or her income, or its income, or the person's income, so that the last dollar spent, however much money spent on that particular good, yields the same amount of marginal utility per dollar of the other good. So in this case, if you really want to consider how much satisfaction you're getting per dollar spent, per your dollar spent, we're going to take the following formula. The marginal utility, this is marginal utility, not utility, this is important. Marginal utility of the good A and the marginal utility of good B, they both have to be equivalent when you divide them by the price of good A and divide it by the price of good B. Notice that this is marginal utility. Marginal utility. Not total utility, not utility by itself, it's marginal utility. Marginal utility divided by the price of the good. Marginal utility of the good divided by the price of the good. If you have two goods and you have the marginal utility and you have the price of the good, divide each good by its price, the marginal utility by its price, and the marginal utility of this other good by its price, divide them together, and if they are equivalent, that may also provide you the optimal consumption bundle using a marginal utility per dollar maximization rule. So for example, so here we have the numerical example of a utility maximizing rule combination for two goods using marginal utility divided by the price of the good. So suppose we have a drink and we have a burger. So we're looking at how many drinks and burgers can we consume. We have the first unit of a drink and the second unit of drink, first drink, and the first burger. The first drink gives you a marginal utility of 5. This is marginal utility, not utility. You have to be able to differentiate utility. Utility is just the satisfaction. Total utility is the total satisfaction added together. Marginal utility is the change in satisfaction. So that's why we're making sure that you identify that difference. Marginal utility is what is here. So you take the first unit of the good, gives you marginal utility or additional satisfaction of 5 utils, marginal utilities. So you take that marginal utility, and you divide it by the dollar value, which is $4. That's how much it's worth, $4 the drink, and that gives you 1.25. Notice how this is 1.25. This is 1.25 marginal utility per dollar. This is utilities per dollar. That's the satisfaction per dollar. How much satisfaction is your dollar giving you at 1.25 utils per dollar? For marginal utility of burgers, the burger gives you 12 marginal utilities of satisfaction. You take marginal utility divided by the 12 marginal utility divided by the price, which is 8, and that will give you 1.5 units of satisfaction. Notice how this one, 1.5, is not equal to 125. So we're not going to take the first combination, which is the first drink and the first burger. That's not going to give you the optimal fulfillment. Then you take a second drink that gives you marginal utility of 15 units. You take those 15 units of utils of satisfaction divided by the price, and that gives you 375 satisfaction per dollar. And then you take the second burger, marginal utility, which is 24 divided by the price of the burger, which is 8. That gives you 3 units per dollar, 3 utils per dollar. So you take the third drink, another drink, that gives you a marginal utility of 25, and that gives you 25 utils divided by $4, which is the price of the drink. That gives you 625 utils per dollar. So the third drink here is going to give you $6.25 utils per dollar. And then the burger is going to give you 50 marginal utilities divided by $8. That's 6.25. Notice how these two are equivalent. 6.25 marginal utility per dollar of a burger and 6.25 marginal utility per dollar of a drink. So you're going to consume the third drink and the third burger to have an optimal combination. And notice how the other ones are not equivalent. They're somewhat equivalent, but they have to be exactly equal in order to have an optimal combination. So here you can have 3 drinks and 3 burgers and have an optimal bundle. If this is the case, it's 1-to-1. Now, from the utility to the demand curve, it's important to point out that there's a relationship. The utility maximizing behavior of individual consumers let us know that there's a relationship to the downward slope of any demand curve in the market. And the demand curve is traditionally downward sloping. If you recall from economic analysis, supply and demand is downward sloping, and the supply curve is upward sloping. We have the following relationship. The price is on the vertical axis, quantities is on the horizontal axis. The consumer maximizing utility behavior explains why the demand curve is downward sloping through main channels. 2 main channels help explain this concept: the substitution effect and the income effect. With the substitution effect, if the price increases, the traditional law of demand relates that the higher price leads to a lower quantity demanded. If you look at the marginal utility per dollar equation, it's marginal utility per dollar divided by the price. If the price increases, you have marginal utility per dollar, which is divided by the price. What happens is the marginal utility is already subject to diminishing returns, because the more you eat, the less satisfaction you may experience, the principle of diminishing marginal utility. If the price increases, then the marginal utility per dollar decreases even more, and that leads potentially to a substitution effect. If the price increases, the consumer receives even a lower marginal utility per dollar on the good and substitutes the good that's providing less satisfaction to the consumer per dollar for an alternative. And the income effect states that as the price increases, the purchasing power of goods and services decline. So if you have higher price, the purchasing power ability declines, and the substitution effects letting us know that your marginal utility per dollar spent is declining. As the price rises, the demand curve is downward sloping. There's an important relationship between the marginal utility per dollar and the demand curve graphical illustration and the effects of demand. This is a brief highlighted analysis as to why the demand curve has a relationship to consumer maximizing utility behavior and the relationship to its downward slope. Later on we can discuss as to more why it's downward sloping. So the income effect here, we're looking at the increase in price increases, real purchasing power declines. things become more expensive, your purchasing power ability or your budget is able to buy less, and you have a lower income effect. In this case, your income buys less. It affects your purchasing power ability. The demand curve may be downward sloping, and the substitution effect is also present. An increase in the price leads to consumers to substitute the product for an alternative for something else, given that marginal utilities are being affected, and the consumer may want to optimize the utilities, and it substitutes the product for something else as well. When we're looking at the applications of utility, it's very interesting in some cases. We tend to buy goods and services that, in our minds as consumers, provide you some form of satisfaction, some form of enjoyment. And one of those things is diamonds for engagements. Often cases, we spend a lot of money in diamonds to provide some form of perceived satisfaction, perceived enjoyment, perception of fulfillment, and we value a little bit less other items, like water, for example. So we have the diamond water paradox. So why do some goods that are essential to life often have low prices, and other goods that are not essential to life have higher prices? And it really depends on the value that people place on those items and the perceived perception that is received from the person. So in this case, we have the water diamond paradox. It's a very interesting situation. A diamond is not essential to life, but it can cost thousands of dollars. And if you give a diamond to someone significant, they have a high enjoyment or a high level of utility for the special occasion. But often cases, water is really essential if we can have relatively low price water situations in some municipal sources, or is access to a lot of people, although it's very essential. But you can argue that water prices have increased over time, and only those that can afford it can buy the product, and others can't. So, but think about, for example, buying the expensive jewelry, buying the expensive clothes, the expensive cars. All of those have a perceived satisfaction that are not essential to life, but are highly valued in some situations. And we undervalue sometimes things that really matter. So there's the application of utility. The consumer pays for an enjoyment, an experience, a fulfillment. And sometimes it may not pay for other items. Now, as we switch towards consumer behavior in terms of the products that we buy, we go into behavioral economics and how we make decisions based on the preferences of consumers. And behavioral economics helps us analyze how we make decisions and our mental processing of making decisions and our optimal decision making. So behavioral economics is a very interesting science that combines psychology, economics, and our decision making process. It also focuses on improving outcomes by improving decision making based on our behavior and based on our likes and dislikes and preferences. And it combines psychology and economics into neuroscience, or a branch of economics that is very interesting when it comes to behavioral economics and behavioral applications of decision making. Now, the idea of economics and psychology being combined is relatively a new subject that helps explain a lot of consumer behavior, a lot of consumer trend, a lot of individual behavior, and it's quite interesting and very helpful in some situations. So let's take a look at behavioral economics. Behavioral economics helps predict that often cases individuals will buy more of one good and less of another particular good until the marginal utility per dollars our ratios or equations are relatively the same in some situations. So you buy more products, less of other goods until you feel satisfied per dollar spent. So a lot of the things that we buy now have to do with prices and income. So in traditional economic theoretical models, most individuals are assumed to be rational and self-interest and consistent. Behavioral economics often shows that sometimes individuals are not that consistent and may not be fully rational and may behave a little bit differently given the situations and given the behavioral brain conditions of that person. So our brain is a very important muscle, and it's one of the most important factors of any individual decision maker and any decision that is made by any individual. So it's always functioning and it's always generating economic decisions that tend to be important for any individual, whether it's reasonable decisions, whether it's an emotional-based decision, memory-driven decision, or any type of decision that is crucial to the individual person at that particular point in time. So our brain is one of the most important factors that allow us to make decisions, conscious decisions, or rational decisions, and some subconscious decisions. So our brain may be broken down into two categories: the limbic system and the analytical system. Sometimes people are highly analytic when they make decisions, and sometimes they're highly spontaneous in making decisions, very emotion-driven decisions. So the limbic system, in this case, it deals with how we feel emotionally, how we respond to people, how we respond to things. Are you highly responsive? Very responsive? Are you going to make a decision based on your emotional standpoint? What's fair? What's unfair? How does this make me feel? And if you have a high reactive limbic system, your decision will be relatively made by the limbic system. If you have, but often they both work together, the limbic and the analytic system. The analytic system deals with calculative, conscious, or organized-based informative decision-making process. Sometimes one is used more over the other, but the idea is to have a balance of both. A limbic structure and an analytic system. Make a decision based on how you feel, but also with information and calculative approaches. So both systems tend to show the activity of the brain when we are faced with a decision, but it actually really depends on the person. So that's why we say that often cases in economics we would like to always be optimal, rational, and calculative decision makers, but the emotional, behavioral aspect of individual decision makers often plays a crucial role in how a decision is made, especially if it's a specific scenario that really increases the limbic system response structure. Now, neuroeconomics is a branch of behavioral economics sector or a field of behavioral economics that studies the brain through some form of high advanced magnetic resonance imaging, MRI, to see what's happening when you make decisions, when you're faced with certain situations, problems, or certain sets of constraints, and you try to solve them using your mental processing mechanisms of the brain, or how your brain processes information. Very interesting science as well. And often it's noticed that individuals are always framed throughout their life cycles, or through our life cycles, we are faced with framing effects. And often framing effects can help an individual make a decision or make an individual respond differently. So framing in economics is often referred to how certain things, certain problems, certain ideas, certain issues, or certain images are presented to an individual, and how the individual may respond to it. It can influence the choices that any one person makes, and can lead to a reversal of preferences. It can change your preferences. It can make you make decisions on constant-based decision making. Advertising is a great example of framing effect. Advertisers constantly frame the consumer with images, with commercials, with certain things to capture the individual decision maker to buy a product. So it influences your current decisions and your future decisions, how often someone is framed. In this case, you can actually argue that even at early stages, framing is crucial in how the individual develops in later stages of life to make important life decisions. What he or she or what that person, whoever that person may be, is currently framed. It's currently framed by and how it's shaped. But when we're looking at the theoretical component of behavioral economics, we have prospect theory. Prospect theory focuses on the framing effects of advertising. The framing effects of advertising and a lot of things that are constantly framed to your brain receptors alter the psychological aspect of a consumer. It's very vivid, and that's why advertising is crucial in today's world, because the quicker the information that is transferred to the consumer via phone, via social media, and so on, it can really change the consumer's spending behavior. So any frame that alters whether consumers consider a situation to be a consumption gain or to be a consumption loss will affect the consumption decision. And advertisers have used this for years and years and years. And billboard advertisements, commercial advertising, nowadays with social media platform advertising, in terms of how quickly they can frame a consumer. So the advertising and framing effect has an important relationship in terms of consumption. We often see that individuals, when they buy goods and services, or when they hold something that they have purchased greatly, or that someone has given to them, or when someone has earned something with hard work, or when they have a special gift that someone has given to them, there is an endowment effect. People may place a high value on something that they own or that is of importance to them, and they cannot have anything else. They cannot replace this item because it's of high importance and high value to this person. This is when you endow something with a strong value more than financial means. Monetary compensation cannot resolve the endowment effect of when someone has endowed someone, some product, some good or service, because it's a perceived value to the person. Often cases we see that situation. If it's a particular good or service, then it can be replaced. But if it's a gift that someone has provided to that person, or if it's an idea or a particular good that someone provided to someone, there's a strong attached endowment, emotional value to it, that if it's lost, broken, or misplaced, it could be a hard time getting over it because you value for it. Especially when you work hard for something and you earn it and you buy something, then you endow a lot and you take care of things a lot. So it really depends how the endowment effect is applied to certain things, not just physical items. Another thing that we notice is that when you compartmentalize certain things, things are, in this case, allocated differently. So dollar spendings could actually differ. The idea here is that when you spend X amount of dollars in different goods and services, people may value things differently. Or when you allocate money in a different location, you may actually value things in a different manner. This is compartmentalizing your spending. Is $1 always worth $1? If you buy something that is of rarity and it's unique and it costs you $1, it may actually be worth more in your mind because you got it from somewhere else. Depending where you bought it. If you bought it in a remote location and there's no others in this area, or you can just buy any random item at a local store. So people tend to potentially treat money differently depending on where it comes from and depending on where it's spent. So sometimes $1 may be good for someone and maybe not be for other people. You can actually see that often cases where people have $1, it means a lot to them, and for some people, $1 may not mean a lot to them, depending on where they are, where they're located, depending on a different location, different situation. What $1 can do, it's different for different people. People that may have high income levels, $1 may be just $1. People that may be in need of $1 may really value it and actually use it for something important. It really depends. So compartmentalizing is actually an important aspect as to when people value dollars differently, especially in different situations. The dollars are valued differently in different locations or in different situations. Those are different than endowment effects. The endowments are different. It's when you value something, some goods, and you cannot replace them. Compartmentalizing is when you spend something and it's unique and you value it differently based on the situation. Now, the concept of utility, it's a very unique situation in regards as to utility maximizing behavior. We're able to cover utility, level of satisfaction, total utility, marginal utility, and marginal utility per dollar. And we cover the behavioral aspect and some characteristics of decision making. I hope this lesson was well for everyone, and have a good day.